The objective of this lesson is to create equivalent fractions with area models and relate the models of the fractions with math equations. In third grade, students explored equivalent fractions. This lesson briefly reviews those concepts and introduces the multiplication aspect of multiplying the numerator and the denominator separately to make equivalent fractions, such as 2 times 1 over 2 times 2. Let's take a look at our first problem. George and Vera each had an identical candy bar. Neither finished eating it, and when they compared how much was left, they had the same amount. George said that he had 1/4 of the candy bar left. Vera said that she had 3/12 of the candy bar left. How can they have the same amount left when the fractions they used to describe the candy bar were different? Let's use some paper squares to help us solve this. First, let's fold the paper in half vertically, then open it and trace over the fold and shade one section of the paper. What fraction of the paper is shaded? It looks like 1/2 or 1 of 2 equal parts. What do you think will happen if we fold the paper in half horizontally? If we open the paper and trace over the fold, how many equal sections are there now? We still have the same 1/2 shaded, but can we name a different fraction as there are 4 equal sections now? 2 of the 4 sections are shaded, so 2/4 is also represented by this model. Although the fractions 1/2 and 2/4 look different, we can see they represent the same amount or are equivalent fractions. How many other equivalent fractions can we find for 1/2? What happens when we fold our paper model one additional time? Now our model shows 8 equal sections, and how many of the sections are shaded? Another way to name this equivalent fraction is 4 shaded parts out of 8 total sections, or 4/8. What do you think will happen if we fold our model an additional time? Now how many sections are there? It looks like 16. How many are shaded? It looks like 8. How would we write this equivalent fraction for 1/2? 8 out of 16 total sections, or 8/16. If we list the fractions we have found so far, 1/2, 2/4, 4/8, and 8/16, can you see a pattern among the numerators and denominators? We can see that the numerators and denominators are even, but do you notice anything else? It also looks like the numerators are doubling, as are the denominators. When 1/2 changed to 2/4, the numerator 1 was multiplied by 2, and the denominator 2 was multiplied by 2. Now let's use a new model by folding our paper into 3 sections. Open the model, trace the folds, and shade one section. What fraction does the shaded section of this model represent? 1 shaded section out of 3 total sections would be 1/3. Let's fold the model in half. Now how many sections are there? It looks like 6. What is the equivalent fraction this model represents? 2 shaded sections of 6, or 2/6. The total number or pieces and the number of shaded pieces is 2 times as many as it was before. 1/3 is equivalent to 2/6 because 2 times 1 over 2 times 3 equals 2/6. Your child will continue to explore many fractional amounts, finding equivalent fractions using models in both multiplication and division equations. After working through various examples, your child can easily answer the initial candy bar problem that opened the lesson: is 1/4 and 3/12 equal? The objective for this lesson was to have students create equivalent fractions with area models and mathematical equations. We met this objective by using hands-on models to discover the use of multiplication and division in naming equivalent fractions.